Welcome to this explainer. If you're a focused learner trying to figure out exactly how the tech industry is shifting right now in 2026, well, you are definitely in the right place. Just a few years ago, traditional software engineering, that was the ultimate goal for builders. But today, we're seeing this massive industry-wide shift toward AI engineering. Literally every company out there, from hospitals to banks to retail stores, wants to build intelligent systems. But how do you actually become the person who builds them?
Okay, let's dive into this, because honestly, this is the single biggest myth out there right now. Do you need a PhD in advanced mathematics or computer science to build AI? The answer is a definitive, absolute no. You don't need to derive complex transformer math from scratch. What you actually need is a concrete roadmap. See, AI engineers aren't these researchers spending years training models from the ground up. Instead, they're the builders. They are the ones connecting pre-trained massive language models to real products that people actually use every day. Over the next few minutes, we're going to lay out a chronological 8 to 12-month learning journey. We'll start with number 1, the AI engineering shift. 2, foundation with Python and math. 3, intelligence through LLMs and RAG. 4, autonomy by building AI agents. And finally, number 5, production, which covers evaluation and scale. All right, let's kick things off with section 1, the AI engineering shift. The industry is rapidly moving away from separating software engineers and AI engineers. Building intelligent systems is just the new baseline now. To really grasp this shift, we have to recognize that traditional engineering is completely deterministic. You write rule-based logic, right? If X happens, do Y. The system behaves exactly the same way every single time. It is totally predictable. But AI systems, they are probabilistic. Given the exact same input, they might actually produce multiple valid responses. They rely on learned context and associations instead of hard-coded rules. And honestly, this completely changes how systems are designed, tested, and deployed from the ground up. And let me tell you, the market heavily rewards the people who can navigate this new probabilistic world. $142,000. That is the median salary for AI engineers in the US right now, with senior roles easily pushing past $220,000. It's wild. This premium exists because the industry desperately needs folks who can build robust, reliable software systems around these pre-trained models. Moving right along to section 2, foundation, Python, and math. So how do we actually get there? Well, step 1 of the first 3 months of our roadmap is absolutely non-negotiable. Python. Python is literally the language of AI. Every framework, every SDK, every deployment tool out there is Python first. Now, once you have those fundamentals down, step 2 is mastering a library called Pydantic. Pydantic is essentially your data backbone. Think about it. When you tell a language model to return structured data, Pydantic is the thing that validates that response before it breaks your entire application. It is absolutely crucial to master this before you even think about touching a large language model. And then there's step 3, the math. Now, take a deep breath and be reassured here. You really just need to understand enough behind-the-scenes math to grasp how models learn. You do not need to become a professional mathematician. You just need basic statistics to understand probability distributions. You need some linear algebra, like vectors and matrices, to understand how words get converted into numbers. And you need basic calculus, specifically things like gradients and optimization, to understand how models reduce their errors over time. And that's literally it. Grasp these concepts, and it's like having X-ray vision into the models you'll be working with. That brings us to section 3, intelligence, LLMs, and RAG. With that foundation built, months 4 through 6 are where things get super exciting. Let's define the single most in-demand AI engineering pattern in the world right now, Retrieval-Augmented Generation, or RAG for short. Look, large language models are amazing at reasoning, right? But they're kind of frozen in time based on their training data. RAG solves this by retrieving relevant live information, like today's weather or maybe your company's private documents, and it feeds that info to the model right before it generates a response. It essentially turns an isolated brain into a reasoning engine that's actually connected to reality. Now, what's really interesting about this slide is that this goes way beyond just writing a clever prompt. This is what we call context engineering. As an AI engineer, you aren't just giving the model basic instructions anymore. You're actually architecting the flow of information. You're designing retrieval pipelines, you're managing the model's memory across a long conversation, and you're setting tight constraints so the model doesn't just hallucinate wildly. You are literally architecting the very environment where the intelligence happens.
Next up is Section 4, Autonomy, Building AI Agents. Once you can build a system that retrieves info and answers questions, you are totally ready for months 7 to 9. But we need to clarify something really important here first. AI agents are not just chatbots. Chatbots talk, but agents actually do work. An AI agent is a dynamic system that can take a complex goal, break it down into a logical plan, reason through the individual steps, and actually perform actions autonomously across external APIs. It's a total game changer. So here's how that workflow actually functions in practice. First, the agent retrieves the necessary context. Second, reasons and creates a plan of attack. Third, and I love this part, this is where the magic happens. It acts. It does this using tools which are increasingly standardized by something called the Model Context Protocol, or MCP. MCP allows the agent to securely connect to external tools so it can autonomously query a database, trigger a refund, or even write code. And finally, the agent evaluates its own output to see if it actually achieved the goal. And that leads us to our final section, number 5, Production, Evaluation, and Scale. This brings us to the final 10 to 12-month phase. So you have a smart, autonomous agent working perfectly on your laptop. Great. Now you have to tackle the absolute hardest part of AI engineering, putting it into production so it serves users reliably and safely. Evaluating AI is incredibly difficult, mostly because traditional software metrics fail completely here. If you use a traditional metric like exact match, it fails because of binary inflexibility, meaning it might mark an AI wrong just because the AI included a perfectly valid trace of its reasoning before giving the correct word. Or consider final answer accuracy. It suffers from what we call trajectory blindness. An AI agent might arrive at the exact right mathematical answer, but only because it made 2 massive calculation errors that coincidentally canceled each other out. Standard testing completely misses these compounding errors in multi-step reasoning. Because of this massive challenge, AI evaluation engineers are among the highest paid people in the industry right now. They have to build modern evaluation systems from the ground up. This involves combining your standard rule-based metrics with really complex systems like LLM as a judge, which is exactly what it sounds like, where you use a massive model to evaluate the nuanced, probabilistic outputs of a smaller model. They also have to evaluate trajectory-level coherence, just to ensure the agent's logic is sound at every single step along the way, not just at the finish line. This entire lifecycle is governed by something called LLMOps. Platforms like Braintrust have totally revolutionized this space by making evaluation the core workflow. Instead of the old ship and pray method, which, let's be honest, we've all done, evaluation-driven development means you're catching regressions and hallucinations in an automated pipeline way before your users ever see them. This is exactly how top teams are achieving massive 30+% accuracy improvements in just a matter of weeks. So the crucial point is that this final infrastructure layer is really where machine learning meets distributed systems. Deploying AI means fighting latency every step of the way. It means meticulous cost management, because remember, every single token generated costs money. It means next-level observability. You aren't just logging simple errors anymore. You are literally logging the thought processes of the AI so you can debug these crazy non-deterministic failures. And of course, it requires strict reliability guardrails and fallbacks just to keep the whole system safe. To summarize this entire journey, I want you to keep this brilliant quote in mind. The next decade won't be shaped by who builds the biggest models. It'll be shaped by who builds the best systems around them. That's it right there. Your goal as an AI engineer in 2026 isn't to go out and train the next massive AI brain from scratch. Your goal is to be the architect of intelligent systems. Your goal is to build products that actually think. Which leaves us with one final, really exciting question. We've walked through this entire 12-month roadmap together. You know the tools you need, the math, the context pipelines, and the deployment strategies. So, armed with all these new skills from this explainer, what intelligent product are you going to build first?